Today we're looking at lesson 5.1, relations and functions. And we're going to look and see how to represent the relations and functions using tables, diagrams, and graphs, and identifying relations that are a function, because sometimes they're not. We should be able to tell the difference by the end of the lesson. So let's look at this vending machine, and we're going to use it to answer the questions below. You'll see a row at the top and a column going down, up and down. What DVD would you receive if you inserted your money and pressed A1? Well, we come over here to A, and we get A1, The Hunger Sports. Simple, simple. B, C2. C2, The Light Night. C, B3. B3, The Amazing Insect Man. So that right there is an example of how to read this picture and representation. Assuming that the machine were filled properly, describe what would happen if you pressed the same button twice. Well, if you press the same button twice, you should get a second copy of what you pressed. So let's put that. Let's see. Should get a second copy. Each time you press a button, an input, you may receive a DVD, which is an output. Okay, now they're trying to get you to think of it in these terms, input and output. What you put in is what you get out. In the DVD vending machine situation, does every input have an output? And explain your response. Well, let's look at it. If I put in A1, I get something, A2, A3. I do not get anything if I get in B1 because it's sold out. I get B2, B3, C1, C2, C3. So let's put that here. B1 is sold out, so it wouldn't give an output. Make sure I said that right. Yeah, B1. Okay. Each combination of input and output can be expressed as a mapping, written input to output. For example, you say B2 gives you the amazing insect man. That's mapping the input, what you press, to the output, what you get. Write as mappings each of the possible combinations of buttons pushed and DVDs received in the vending machine. All right, so for this one, you're going to need a mapping for A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay? So if we pressed B1, I'm just going to copy and paste this little arrow to make it easier. On each one, Hunger Sports, Revengers, Battle Sales. Okay, that's for the A's. Hunger Sports, Revengers, Battle Sales. And then it's sold out. Amazing Insect Man will be. And then on C, we get dependables and then the light night. All right, part B, create a table to illustrate how the inputs and outputs of the vending machine are related. All right, so we just basically put this mapping that we did and put it onto a table. All right, so how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. I need 9 rows, but probably one for the title too, so let's put that at 10 rows. And columns, well, it's just 2 sections, so we need 2 columns. All right, and we'll label the top. We'll put it into, let's say, bold, just to make it easier. And this is the button pressed. And this will be DVD spit out or outputted. Let's just say output. All right, so when I press A1, A2, A3, A4, nope, sorry, start with B1, B2, B3, C1, C2, C3. And then we get Hunger Sports. This one bold, just to make it look better. All right, Hunger Sports, Revengers, Battle Sale. And I just messed up the styling of that, but that's okay. Battle Sale. It's sold out. An amazing insect man. Amazing insect man. And then Dependables and Light Night. Dependables, Light Night. I don't want to copy that whole row. Ugh. Sometimes these editings are weird, but that's fine. We'll just keep it like this. You can see the basic of what I was going for. That is a table of the inputs and outputs. It's what you put in, this is what you got out. Very simple so far, okay? We just had a picture, we read the picture. Nothing outstandingly hard about that. All right, so mapping that relates values from one set of numbers to another set of numbers can be written as an ordered pair. A relation is a set of ordered pairs. So right there, you can write them as ordered pairs. So I'd be like C1 dependables. That would be an ordered pair. And the relation is the set, okay? The whole set. Relation is going to have a variety of representations. Consider these relations, 1, 4, 2, 3, 6, 5, shown here as set of ordered pairs. We can show them in many ways. You have a table, 1, 4, 2, 3, 6, 5, under the X and Y coordinates. You could have the mapping, where you say, all right, this one goes with this one. 1 goes with 4, 2 goes with 3, 6 goes with 5. Or you put it on a graph, 1, 4, 2, 3, 6, 5. Number 5, write the following numerical mappings as ordered pairs. And you see this. 1 goes with -2. And so you'd write it as an ordered pair. 1, -2. 2 goes with 1. So ordered pair. 2, 1. Simple. 3, 4. 3, 4. Yes, you need the parentheses to make sure that you know that it's an ordered pair. 4, 7. Okay. Very simple so far. We're just walking you through it. It will get a little trickier in just a minute as you look at what you've got, but not too much trickier. Check for understanding. Here's the vending machine. I want you to try this one on your own. Okay? you have your pairs. You just follow left and right first, up and down second. You're going to make a table, write the combinations, write the letter number combinations in a mapping diagram. So it looks like kind of like this. That's where we did right here. Okay. So set of ordered pairs, that's where you need these set that runs in parentheses. And there's the letter combination showing a table as a table. That's where we made one using over here. This is a table. So do number 6 to check your understanding of what we're talking about. So number 7, a function is a relation in which each input is paired with exactly one output. Each number you put in can only give you one output for a function. Okay, definition of a function, one output. Compare and contrast the DVD vending machine with a function. Well, right here, each button I press, A1, A2, A3, A4, A5, B1, B2, B3, C1, C2, C3, each one gives me one output. One thing happens when I press each of those buttons. So for number 7, compare and contrast. How is it like it? Okay. Each button pressed does have one outcome. Just like a function. Oop, misspelled that. Hold on just a second. Number 8, suppose when pressing C1 on the vending machine, both the dependables and the light night come out. Depend how this vending machine resembles or does not resemble a function. All right. So we're going to, and we'll say, if that happens, it wouldn't resemble a function anymore. Because an input, pressing the button, would have more than one output. So if I press that button C1, I would get 2 different things happening. And that right there ruins a function. Okay, if you have your inputs and there more than one thing happens when you press that input or put in the input, that is not a function anymore. Okay, and that's the difference. If as long as you can put in one thing and get out another, a 1-to-1, or even if you press a couple of things and get the same thing, like yes, we did press B2 and get the amazing insect man. We did press B3 and get another amazing insect man, but that's still getting one thing when we press those buttons. B2, I got one copy of the insect man. B3, I got one copy of the insect man. That doesn't matter that it's the same thing happens when I do those things. The function would be if I pressed B2, it wouldn't be a function anymore if I got both the insect man and something else, dependables, let's say. So as long as you get one thing that happens when you put in an input, that's a function. All right, 9. Imagine a machine where you input an age and the machine gives you the name of anyone who is that age. Okay? Compare and contrast this machine with a function. Explain by using examples and create a representation of the situation. All right, so if I press the button and got anybody whose age, let's say I pressed 53. Okay, and then it listed Jane and Bob as both 53. That is 2 outputs for that one input. And yes, I'm switching between numbers and words. As long as you're listening to the sound of my voice, you're fine. That is 2 outputs for that one input, which makes this not a function. An example of a situation, math or real life, that behaves like a function and another that does not behave like a function. Explain why you chose each example to fit the category. All right, so we need to think of some things that behave like a function and some things that do not behave like a function. Just any kind of examples that behave like a function. You do one thing and you get another one out, and one that does not behave like a function. It could be math or real life. Okay? Behaves like a function. If I press the number 9 on a calculator, the screen will show 9. Okay, if I press 9 on a calculator and it pops up, that's a function. Now let's see something that does not behave a function. Let's see. Let's say I had these set of numbers. Let's say 1, 2, 1, 4, 2, 3, 4, 4. This set would not represent a function. Because look, I press 1 and I get 2, but I also press 1 and I got 4. That's not a function because I got 2 different outputs for doing the same thing. One gave me 2 different points. Because input of 1 gave output of 2 and 4. That would be not a function, and that would be like the math example. All right, let's look and see. Just scrolling for a second. Let's look and see number 11. Determine whether these are ordered pairs or in equations represent functions. Okay. So 5, 4, 6, 3, 7, 2. That is a function. Oh, you put in a 5, you get a 4. Put in a 6, you get a 3. Put in a 7, you get a 2. You get one thing happens for each one of those. I hope you hear the bell ringing. B, 4 gives you 5, 4 gives you 3, 5 gives you 2. That's not a function. 4 gives you 2 different answers. Okay. I realize when I say answers, I mean like output and all that kind of stuff. 4 gives you 2 different outputs. C, 5, 4, 6, 4, 7, 4. I mean, they all give you the same output, but it's fine because each one only gives you one answer. So that is a function. C is a function. D, y equals 3x minus 5, where x represent input values and y represents output values. All right, this is a function. No matter what I put in, I will get out a number. If I put in 0, it'll give me -5. Y equals -5 if I put a 0 right there. If I put in a 10, it'll give me 30 minus 5, which is 25. Every number I put in will give me a number to come out. Okay. Similarly for E, y equals -x plus 4. Every number I put in for this x, 0, it'll be 4. 2, -2 plus 4. is positive 2. If I put in negative 2, negative 2, that's positive 2 plus 4 is 6. Every number I put in will give me a different number coming out. So those are functions. There's another bell. And 12, using positive integers, write two relations as list ordered pairs below, one that is a function and one is the not. So I already sort of did this using the positive integers, where you did this one right here. Okay, this list would be like a function you could use. This list would be a not a function. This list of ordered pairs is a function. This list I made is not a function. So that's all this wants on number 12. Writing a list of ordered pairs that is a function. That means each one gives you one answer, and one list of ordered pairs is not a function, where each one, some of them might give you a different answer. At least one set of numbers, you press it, you put it in the first spot, I mean the input spot, and it would give you a different number at the output spot. See, 4, 5, 4, 3. That's two of the same numbers input. You got two different numbers output. That is not a function. So hopefully we can see the difference now. Functions, whatever number you put in, you get exactly one number for it. There's only one number that 5 gives me in this set. 5 gives me 4. It doesn't give me 10. It doesn't give me 20. 5 only gives me 4. 6 only gives me 3. 7 only gives me 2. Not a function is when 1 gives me 2, but also 1 gives me 4. See, that but also ruins the whole thing as a function. So hopefully we've seen the difference between functions and the relationship between today. Go ahead and try these other problems. Okay, I give you examples. I give you some charts. Give you some thinking questions. Try those.